Beth.
Hey, Carly. What's your favorite screen name?
Oh, so one of the names that I really like to use is K-means Carly. And this may just sound like I'm really conceited, but it actually has a statistical technique embedded into it, the K-means.
Yes, so K-means is one of the simplest machine learning algorithms, and people love to use K-means because it is an unsupervised clustering algorithm. It's going to find which data points are best associated with itself. And this is the idea of clustering as a whole, is if I have a number of data points, and I'm going to represent them just as a two-dimensional graph of x's and y's, but you can actually do this in any dimensions. You can have 7, 8, 10, 100 different variables, and K-means clustering still works.
Exactly.
So our x values are going to, every point's going to have an x value and a y value. And there are going to be a number of different points, and these points may look roughly random. And this is going to be the input into any clustering algorithm, where we have a whole bunch of x values and a whole bunch of y values. And what any clustering algorithm does is the clustering algorithm is going to look at all of the data and say what clusters can I draw? What circles can I draw on this graph that best encompasses all points that are the same? And here, as a data scientist, you may need to initiate this algorithm with a specific number of clusters. So Carly, if you look at this graph, what's a good cluster size that you might start with?
Ooh, so this is interesting. I would say 4. It looks like there's kind of one right here, maybe one right here, one here, and one here.
Exactly. So if you initialize K-means clustering with a K is equal to 4, it's going to find the points that best fit each cluster. And I'm going to include this guy in this cluster.
One's a little questionable.
But every single cluster is going to have a set of points that are defined by that cluster. And now we have 4 different clusters. So this may be the result of a K-means clustering with K is equal to 4, so 4 clusters. We may also have identified it with just 2 clusters.
Right.
So
that was my second guess.
Yeah, another universe, maybe just 2 clusters, where I see that the left-hand side clearly has a nice clustering of points together, and the right-hand side clearly has a nice clustering of points together. And what this algorithm does is it lets us know that all of these data points inside a particular cluster are going to be similar in data. So what this allows us to do is it allows us to do further analysis to say, why are all of these points so close together? Is there some other factor about these points that is worth identifying? So clustering is one thing that it's great about recognizing anomalies. So some of the first uses of clustering was actually looking at fraud. So if you have a general series of transactions, everyone generally makes the same type of transactions once they know your transaction pattern. So as a particular perfect person in a particular socioeconomic category, there's a pretty good model of about what you're going to spend money on. So if you randomly then decide to make a $1,000 purchase on clothes, and that's outside of your normal behavior, that's going to be a point that probably looks like it's in a different cluster. And now we have a point that doesn't look like it's your type of spending. It doesn't actually, you don't have to identify exactly what your type of spending is. It just knows that a cluster of spending represents your style of spending. Anything outside of that cluster becomes an anomaly.
Yeah, and that's really key to detecting fraud. That's a really cool way that we can use machine learning to do that and to protect people.
So clustering is just one example of a unsupervised machine learning algorithm. And we're going to dive into the simplest way to cluster, which is an algorithm called K-means clustering. And this is just one of many different clustering algorithms. But this one is really simple to use and simple to calculate. So we can actually run it by hand before we actually see Python run it thousands of times, all really quickly automatically. But it's a really simple clustering algorithm to understand how a computer is creating these clusters and how we can use these clusters to do prediction on unknown data.